Rational functions. Rational functions are functions that can be written as fractions. For this lesson, our rational functions will be a polynomial over a polynomial. We're going to identify various characteristics of the functions and then use that information in the graphing calculator to draw graphs of the functions. So we're going to learn about each part separately, and then at the end we'll put it all together. The first thing we want to identify are x-intercepts. These are where the graph crosses the x-axis. So to find it algebraically, we're going to set the top of our function, the numerator, equal to 0. So for this first one, x minus 5 equals 0, so x equals 5. So that means on the x-axis, I know that the graph is going to cross at 5, so there will be a dot there. The y-intercept is where the graph crosses the y-axis. So this is the y value when x is 0. To find it, we'll replace all of the x's with zeros. So we'll have y equals 3 times 0 minus 5 over 2 times 0 plus 3, which is negative 5/3, or negative 1 2/3. So on the graph on the y-axis, at negative 1 2/3, we would have a dot. Now, when we figure out an x value that causes the bottom of the fraction to equal 0, we know that the graph breaks apart or has a discontinuity at that x value because you can't divide by 0. So on a graph, this is indicated by a vertical dotted line known as a vertical asymptote. And so to find it, you're going to set the bottom or the denominator equal to 0. So we know that if x was 2, the denominator would be 0, which is not allowed. And what that looks like on the graph is at 2, at x equals 2, you'll have a straight up and down dotted line. Let's find vertical asymptotes on this next graph. There can be more than one on this next function. And so you have to factor before you can do that. Always factor first. And we have then x minus 3 over, and then the bottom would factor into x minus 5, x plus 3. So if both of those factors were set equal to 0, we would have x equals 5, x equals negative 3. So those are where the vertical asymptotes would be on the graph. So you would have straight up and down dotted lines at both of those places. Also horizontal asymptotes. To locate these, we must define some terms and then look at a set of rules. The first term is degree. The degree is the largest exponent of a polynomial. And then the second term is leading coefficient that we'll just call LC rather than writing all that out every time. And that's the number in front of the letter with the biggest exponent. So for this example, the biggest exponent is 3. So that's the degree, and then if you look to the front and see the negative 7 in front of that x cubed, that's the leading coefficient. So that leads us to the horizontal asymptote rules, and we're going to let the letter A stand for the degree of the numerator, the letter B stand for the degree of the denominator, just for some shorthand, and there are 3 situations. The first situation is that A is greater than B. In that case, there would be no horizontal asymptote. So for this example, the degree of the top is 3. So we'll say A is 3. The degree of the bottom is 2, so B is 2. And so since A is greater than B, there is no horizontal asymptote. The second situation would be if A is less than B. If that's the case, the horizontal asymptote is y equals 0, which is just over the top of the y-axis. And so in this example, the degree of the top is 0. If there's no variable at all, then the degree of the top is 0. And then the degree of the bottom would be 1. 0 is less than 1, so the horizontal asymptote is y equals 0. Then the final situation would be if A equals B. So for this example, the degree of the top, which is A, 2. Degree of the bottom is also 2. And so the horizontal asymptote is y equals the leading coefficient of the top, which is 2, over the leading coefficient of the bottom, which is 3, 2/3. So let's practice finding vertical and horizontal asymptotes. In this first example, vertical asymptote is where the bottom would equal 0. So if x minus 3 equals 0, the asymptote would be at 3. For the horizontal, we have to use our rules. The degree of the top would be 1. Degree of the bottom is also 1. So it's the leading coefficient over the leading coefficient, which would be 7 over 1, or just 7. The second example, we would need to factor first. So it's x minus 7 times x plus 7. And our vertical asymptotes would be at positive 7. Hang on, that should be an x, not a y. At positive 7 and at negative 7. For the horizontal, you've got to go back to the unfactored form. So the degree of the top would be 1. Degree of the bottom would be 2. When the top is less than the bottom, then the horizontal asymptote is at y equals 0. For the last one, the bottom is already factored. For the 7x, the vertical asymptote would be at x equals 0, and then the x minus 4 set equal to 0, x equals 4. But the horizontal, you want to use the unfactored form. So if you think about the bottom being multiplied back together, that would be 7x squared minus 28x. So the degree of the top is 2, degree of the bottom is also 2. So the horizontal will be leading coefficient over leading coefficient, y equals 6 over 7 for the horizontal. For your homework problems, there are several steps then to draw these graphs, and these all incorporate everything we've just gone over, plus using the graphing calculator. So these are the steps to follow and to graph by hand, finding the x-intercept, finding the y-intercept, the vertical, and the horizontal asymptotes. Then we can graph the original function on the calculator to see how the curves go, and we'll copy those curves onto the graph. And then finally, we want to name the domain and range. So we're going to graph f of x equals 4x minus 4 over x plus 2. So let's make a little list of all the things we're going to do by hand. First, the x-intercept you get by setting the top equal to 0. So x equals 1. The y-intercept, you replace all of the x's with zeros. Y equals 4 times 0 minus 4 over 0 plus 2, which would be negative 2. Vertical asymptote, bottom equal to 0. So that would be at x equals negative 2. Horizontal, degree of the top is 1. Degree of the bottom is also 1. So it's going to be leading coefficient over leading coefficient, y equals 4 over 1, or just 4. So we need to go ahead and draw all of those things on the graph by hand. X-intercept at x equals 1. Y-intercept at negative 2. Vertical asymptote at x equals negative 2. Horizontal at y equals 4. Now, into the calculator goes the original function, and make sure you put all of the top in a parentheses, all of the bottom in a parentheses, into the y equals, and graph that. Make sure you look at your notes to see if there are any special windows. Here's the picture of it. Now, if you have an older model of the calculator, like a TI-83, it draws the vertical asymptote in there for you, so don't be confused by that. Now, once I have it graphed on the calculator, then I'm just going to copy the curves that I see onto my graph. And finally, we'll finish up with the domain and range. Remember, the domain is all of the x's from the farthest left to the farthest right. Our graph is broken into 2 pieces, so our domain will be broken into 2 pieces. So in the upper left-hand corner, the farthest left the graph goes is negative infinity, and then it travels to the right until it hits the asymptote at negative 2. it can't actually touch it, so we use a parentheses, not a bracket. Then the lower right-hand curve, the farthest left it goes is the asymptote at -2, and then it goes to the right forever. The range, all of the y values from low to high. So the lowest curve is the one on the lower right, and the lowest it goes is -infinity, and then it goes up until it hits the asymptote at 4. And then on the other side, it starts at 4, and then it goes up forever. Let's try one more. For this one, we want to do all the same things. Starting with the x-intercept, if we set the top equal to 0, we end up with x equals 2. Y-intercept, fill in zeros for all of the x's. So 4 times 0 minus 8 over 0 minus 4 times 0 plus 1. So that would be -8 over -4, which is +2. Vertical asymptotes. This one is already factored, and so the bottom equal to 0 would give us 2. X equals +4, x equals -1. To do the horizontal, we want the unfactored form. We really don't have to multiply all the bottom back together, just the x's, so that we see the degree is going to be x squared. It's going to be a 2. The degree of the top is 1. Degree of the bottom is 2. When a is less than b, then the horizontal asymptote is y equals 0. So now we're ready to put that on the graph. And we have an x-intercept at 2. Y-intercept is also at 2. Two vertical asymptotes, one at 4 and one at -1. Then horizontal at y equals 0, so that's right on the x-axis. So now I need to go back to the original, everything in parentheses, top and bottom, y equals, and draw the graph, which you can see here. And we have 3 curves to copy over. Make sure your curves cut through the intercepts that you've drawn. Domain and range. Our graph is in 3 sections now, so the domain will be in 3 sections. The farthest left starts at -infinity and continues until it hits the asymptote at -1. Then the part in the middle, the farthest left it goes is the asymptote at -1. Farthest right it goes is the asymptote at 4. Then the section on the far right, the farthest left it goes is the asymptote at 4, and then it continues to the right forever. The range is a little tricky. It seems like maybe it should be broken into 3 parts also, but notice this curve in the middle goes down forever, and then there's no breaks, and it goes up forever. So the curve in the middle covers everything that the other 2 curves are covering. So really we only have to worry about that part in the middle. And it is from -infinity to +infinity, or if you prefer, you can write all real numbers.